Hello, I'm Austin Lair. I'm a senior over at Park High School in Livingston, Montana. I am part of Ms. Delakich's physics class, and we have been doing the microgravity labs over the last couple days. I decided to go with magnetic motion and kind of just look into and see the results of magnetism under free fall conditions. For this experiment, we used these materials here. We used a box that was filled with just stuffing and packing peanuts. We had this box, which we actually performed the experiments in. These flashlights were to help with some of the lighting. We noticed early on in the experiments that the lighting was not good with the camera that we were using. This Velcro, we Velcroed our experiments down to. And then we climbed on this ladder with the lid, reached to about the top of the ceiling, just a little bit over, centered ourselves over the box, and then dropped. And it was roughly a 0.6 second drop. And for this experiment, my setup was as follows. I had some cogs that I glued together, attached to an Allen wrench, which you can't see, which is this component right here. I had a few metric shaft collars, which then led to another Allen wrench that I could screw down this shaft collar with to hold this magnet in place, and this was all put together with super glue. Then I had a non-ferrous brass rod, which I attached a ceramic magnet washer to, along with some fishing line, and I placed it roughly 10 centimeters away from this magnet up here. And the first run wasn't very good. It did a little bit, but not much. But the second run I set up, and it had some very interesting things happen. I did some motion diagrams as to what actually happened when I slowed down the video and watched it at about 3 times the reduced speed. At first, it was just sitting there when I was holding it up, and as soon as we started dropping, we noticed that the magnet started flying towards the other magnet, and eventually it was held in place until impact, where it fell away and dropped. But for this, through some motion, force diagrams, we noticed that there were 4 components of force that were acted upon this magnet right here, M2, when it was at rest. But because of the free fall condition, almost every one of those components but the magnetism was taken away. Because there was no more gravity, well, I can't say there was no gravity. Gravity was limited, so that was no longer a component because the object was in free fall. That was taken away. Then we had normal force, which didn't need to act because gravity was gone as well. And then friction, because it was not touching the surface of the board, was also gone, leaving just magnetism acting upon the magnet. And eventually, that was when it was flying towards the other magnet. Eventually it was held back by the tension of the fishing line and suspended for a short while, which was a very interesting aspect of this experiment we did. And this did kind of prove my hypothesis that the forces of magnetism would increase after some other forces were taken away. It would be much more pronounced because those forces aren't acting upon the magnet as well. I worked alone for this for the majority of the experiment, and I had a few pointers from my awesome assistant, Mr. Hall. He helped me with some of the diagramming and force diagrams. I ran those by him, and initially I was going to put the force diagrams for both the anchor magnet and the experimental magnet, but since this is pretty well anchored in place, there would be almost no reason to put the force diagram on there, in his opinion. So we took those out, and this is kind of what we were left with. But thank you for listening, NASA. I'm Austin Lair at Livingston Park High.